Questions? Number 6. So we're in 1.3, right? And 6, sketch the graph and determine the limits. That's the one? All right, so let me try and go pretty quick through this. Let's see, I am recording. So I have to graph this piecewise function. And it's going to be 1 plus sine x. So just real quick here, if this is 1, this is 2, negative 1, negative 2. Sine x looks like this. Right? That's sine x. Plus 1 moves the whole thing up 1. So I want to go up 1 like this, come back down. That's sine x plus 1. But I'm only interested in it when x is less than 0. That's what it says on here, right? So I actually want to the left of the y-axis with this sine function. So if I carry it backwards, it would have gone like this. Let me get rid of that. Does that make sense? Okay. Now I'm going to leave an open circle here because I don't know what's happening there yet. I'll look at that in a second. The next one is cosine x, but it's between 0 and pi. So I'll do that in green. Cosine starts up here, goes down like this, and then it continues up like that. But I only want it between 0 and pi. Pi is halfway, so I will cut this right side off also and leave that as an open circle. And then it needs to look like sine x if x is bigger than pi. So again, sine look like this. And bigger than pi means from the middle here on. So from here to here, and I can just keep going with that and put an arrow. Do you follow that part? Okay, now it says in the middle of the piecewise function, it says cosine x if x is less than or equal to 0. The little equal under the inequality means you do want a dot there at 0, so you want to be on the cosine function, which is up there. So it actually brings the two together. And then at pi, it's also on the cosine function, so a dot there. And everything else is left open. Any questions there? So it says, sketch the graph of the following function and use it to determine the values of a for which the limit exists. So where does the limit exist? Well, how about over here? Anywhere over here? If I were to stop at any one of these points, let's say I stop here, then if I come in from the left and from the right, are we going towards the same place? Yes? So the limit would exist there. Actually, it would exist anywhere on that graph, the red part. How about at this point right here? At exactly that point. If I come in from the left, where am I headed? To 1. If I come in from the right, where am I headed? To 1 also. So it looks like it's okay there. And anywhere in here, in this piece, the limit would exist. I'm talking about anywhere in here. Except when I get to this point right here at pi. Because if I come in from the left, I'm headed towards what? Negative 1? But if I come in from the right, where am I headed? Over here to 0. So because I have a jump or a break in the graph there, my limit will not exist there. Now to the right, what about to the right of that? It looks good everywhere? So it says find the values of a for which the limit does exist. So doesn't it exist everywhere except pi? So you would say something like negative infinity to pi union pi to infinity. This would be the a values that the limit would exist there. The only place it does not is at pi. So I jump over pi, just skip pi. Does that help Okay. Was it more about how to write the answer, or? Okay. Yeah, okay. I got you. I got you. Any others? Yes? 13? 13? Limit x approaches 0 of sine x over x plus tangent x. You were confused in what part of this? Yes. Because you're approaching 0, right? So if you look at a number line, here's 0. They ask you to plug in plus or minus 1. So here's -1, here's +1, right? Then they say plus or minus 0.5. So that's here and here. Then 0.2. So here and here. And then 0.1. You get what's happening here? So you're actually alternating. You're approaching here from the left and the right. And you're getting closer and closer to what, though? 0. And they just want to know how it behaves. As you get closer to 0, what are your answers on your calculator getting closer and closer to? Were you able to determine anything? Uh-huh. What did you get? Okay. And so as you got smaller, as you did, oh, you got the same numbers when you did plus or minus. Is that what you're saying? Okay, yes. But as you went to the next one, -0.2, what happened? Okay. Because what you're supposed to do is just keep marching closer and closer and see where your answer is getting closer and closer to. Did anyone get this one? What did you get? 1/2? So it looked like if you were to make a t-table, if you started out at 1, then you went 0.5, then you went 0.2, then you went 0.1, then you went 0.05, then oh, 0.0. Then these numbers on the right side should get closer and closer to 1/2. That's what we're trying to get here. And then when you do the same thing with the negatives, those should also be getting closer and closer to 1/2. Is that okay? So it looks like the answer is 1/2. Yes. Where'd you get it? Do you have it with you? Bring it next time. Yeah. Yeah. Okay. Well, you have to get on your calculator. You have to put in sine of 0.05. Are you in degree or radian mode on your calculator? That's probably the issue. What mode do you have to be in? Radian mode. Because these are not degrees we're plugging in, or else they would have a degree symbol. Yes. So do sine first, write it down. Are you recalculating over there? Were you in degree mode? Okay, that's probably the issue. In mathematics, the only time we ever use degrees is if the problem says degrees. Other than that, we're always in radians. So that'll make a huge difference in your answer. Try it again and see if you come close to the 1/2 on your own time. Okay, so my plan was to give a quiz today, but I'm going to be nice because it's Monday, and instead I'm going to offer a bonus, and it's right now, okay? Real quick, take out a sheet of paper, close your books, close your notes real quick. This is a bonus question. Just put your name on the top, put today's date, put bonus. Everybody has to turn something in, all right? But I'm not going to penalize you if you don't get it right. You ready? In the video for today, there are two important formulas that I said every student should know. What are they? They're two limits that everyone should know. So what are they? And when you're done, you can turn it in. You want to keep it? You can keep it. If you feel bad about wasting paper. Well, you could have still watched it and just didn't really think through it. Like, I'll save this paper and I'll use it next time I have a fire in the backyard. I'll burn it. That way it won't be wasted. Okay? I'll put it all back into the atmosphere. Kill the ozone, yeah. Well, I'm glad I didn't do a quiz. Last call. All right. Anyone else? Anyone else? So you remember the difference quotient. That's good. Hey, you might get points for that. Today we're supposed to cover on our schedule section 1, chapter 1, section 4, right? That's what's on our schedule. You're supposed to try and watch the video for 1.4 before you come to class, right? That's the whole idea behind this. And in 1.4, I give you a bunch of formulas. And then right here, note, two very important limits. Know these. Now, as a student, as a calculus student, if the instructions are to look at this stuff before you come to class, and inside it, it says know these, the expectation is that you know that. Does that seem reasonable? Just kind of like if, I guess what I'm trying to get at, without trying to baby everyone in here and try and sound like I'm preaching to you, how many engineering majors do we have in here? Okay? You got to be real with yourself. It's like a job, right? If your employer says, look, I want you to do this. Next time you come in, be prepared for this. And you show up and you're not, what's going to happen to you? Goodbye. Goodbye. This is a job. To me, it's a job. You treat it like a job, all right? Now, it's a voluntary job. You don't have to be here. But if the expectation is that, look, you need to know this, then you need to know it, all right? Now, if you think that's too much to ask, you're in the wrong field. If you think my bar is too high, when you transfer to a university, wait till you see what level of competition you're facing. I mean, that is when you get the reality of, oh, wow. These are people who have educations in different countries where their math background is so much better just starting off, you know. So the only thing you can do to help yourself is at least be disciplined enough, you know, put in the effort for it, okay? All right. trying to walk that fine line of not pissing you off, you know, but at the same time, like kind of making sure you understand that, look, our country, right? I mean, would you kind of agree part of the problem that we have in the country is just that everyone just expects that it's just going to happen? I'm just going to say, I'm going to be an astronaut, and then I'm just going to be an astronaut. I'm not going to be an astronaut unless I actually try to be an astronaut. I'm not going to be an engineer unless I try to be an engineer. At some point, you have to hold yourself accountable. So, all right. Those are the two things I wanted. If you gave me one of them, I'll give you full credit. If you gave me both of them, I'll give you even more full credit. All right, we need to get through. We have a lot to do today. It's going to start to get pretty intense here. I had one student attend the review session on Friday that I announced, and I think I had said that review session I was going to cover stuff that we haven't seen. And can I point you out? Yes? Was it kind of intense? Okay. So what we're going to see today is kind of intense, and it was probably a good thing that you saw it once already. So just be ready, because the algebra is going to get real crazy right now. And you have to kind of stop me if you are like, whoa, I have no idea. Or you need to come visit me in my office hours. I think in the review session, I spent a lot more time like on details. Here, I've got to get from point A to B today. I've got to cover the material. So let's see how it goes. Everything we've done up to this point, right? What you did in your homework, you were plugging in these values for a table, on a table, and we were trying to get what the graph is doing by just using a table. Or if someone gives us the picture, we can kind of tell what's happening as we approach both sides. But how do we find limits when we don't have any graph and we don't want to do a table? We have to figure out a way of calculating the limits. So we have what are called the limit laws. These are the things we can and cannot do with limits. If you're trying to figure out what's happening to a function as x approaches a, and you have two functions that are being added together, you're allowed to split it into two separate problems and look at each one individually. The next one says you can do the same with subtraction. The next law says if you have a constant there, that you can kind of go past the constant and look at what's happening inside. The next one says if you have a product of two functions and you want to know what's happening, you can look at each one individually and then multiply their answers together. Division works the same way. If you're trying to figure out what's happening with the quotient of two things, you look at the top and bottom separately, get those two answers and divide. Same thing with powers. Trying to figure out what's happening to something to a power, figure out what's happening to that something first, then when you get the answer, raise it to that power. The limit of a constant is the constant. I can show you a picture for this one. If I have a function that is constant, it means it's flatline like this, right? If I ask you, where is it approaching? If I come in from the left and right to any point, where is it approaching? Well, whatever the constant value is of the function, right? Whatever it is, it's always going to stay that way. So that's why the limit of a constant is itself. The limit as x approaches a of x is a. We'll see more of this. The limit as x approaches a of x to the n is a to the n. In both of these problems, it looks like all I did was just replace x with a. Same with this one. This one says you can pass the limit through the root. All of this stuff really doesn't make a whole lot of sense to us right now because we haven't tried doing anything yet. But I'm going to be working through the problems today. I'm going to be reverting back to these laws and saying, okay, we can do that because this says we can. All right, direct substitution, again, I'll point that out later. And we're just going to do a bunch of problems right now. That's all today is going to be about. How do we do limits algebraically? So I'm going to start 1.4. I'm going to start working through some evens here, starting with number 4. Well, You know what? I think I'll start with 12. Okay, what's happening? Limit x approaches 4 of x squared minus 4x over x squared minus 3x minus 4. One of the most fundamental ideas that we could have here to start off is just to understand what this means. And from last class, I hope it kind of came across with my videos. I hope it came across. When we say lim x goes to 4, what we mean is, what does this thing do? How does it behave as we let x get closer and closer to 4, but x is never going to actually be 4? Because that's what the limit means. Don't let it be 4, let it get close. How close? As close as we want. So to start any limit off, we're not doing a table or anything else. To start any limit off, I like to draw an arrow to the side, and I like to do what's called direct substitution, which means just plug 4 in. I know I said x can't be 4, but that's the first thing we always do for every limit. Just plug it in, see if we have a problem. So what's 4 squared? 16, right? And then minus 4 times 4 divided by, let's see, 4 squared minus 3 times 4 minus 4. So on the top, what do you get? 0. On the bottom, what do you get? You get 16 minus 12 minus 4, so you get 0 of 0, don't you? You get 0 divided by 0. This is not a good situation, right? We do not like division by 0. And in fact, anytime we see 0 over 0, from now on, right, anytime we see this, we're going to tell ourselves that this is a bad situation, because that means we're going to have to do some calculus. We're going to have to do something to get around this. What we're going to need to do is some algebra, or as we'll see later, we might have to use some sort of trick. And we're going to have lots of tricks. What you cannot do is sit here and say, oh, 0 divided by 0 is 1, and box your answer and move on, because that's really, really wrong, all right? 0 divided by 0 is why we're here. It's why we're taking this class. Try and get around the 0 by 0. All right, so what we'll notice is that we have a polynomial divided by a polynomial, right? Poly divided by poly. So let's factor. We love factoring, right? In college algebra, they beat you to death with factoring. Why? Because you might need it later, and today's later, right? So let's factor x here, right? We can factor an x out of those two terms. We'll be left with what? X minus 4 on the bottom. This is a quadratic trinomial, right? This is a trinomial. You can factor trinomials using all sorts of different methods. I would hope that everyone here would have a way that they're comfortable with, something that they like, that they know how to factor something like this. I'm not going to teach people how to factor this. That's something you would have to come into my office. We had to sit down, or I would send you to the tutoring lab and say, you need help on AC factoring or whatever. So I would expect that you can get this to the next line, which would be what? X plus 1, x minus 4. Right? X plus 1, x minus 4 would work? Okay. Do you see the good stuff that happens right now? The x minus 4s cancel, don't they? Now, this is a little subtlety, but we need to make sure we pay attention to this. The only time you can ever cancel a factor like this is if you promise me neither one of those factors would ever be 0. Well, what would make both of those 0? What value of x would make them 0? 4, if x was 4, right? Now, I'm going to let x approach 4, right? But I'm not going to let x ever be 4. So it is okay for me to cancel those as long as I never let x be exactly 4. So they're canceled. I'm still going to write the limit. The limit has not gone away yet. I'll tell you when it's going to go away. That's all that's left, right? Now, I'd like for you to let x get closer and closer to 4. Now, closer and closer without actually being 4. So what does the top get really, really close to? 4, right? Because I'm just replacing this x with 4. Well, something really close to 4. So the top wants to head to 4, and the bottom wants to head towards what? 4 plus 1 for 5, right? Is this 0 over 0? Do I have division by 0 here? And no problems, right? So that is going to be our answer. Our answer is equals 4 divided by 5. Very, very important that you understand. I am not saying that if you plug 4 into this, you get 4/5. What I'm saying is that as you get closer and closer to 4, this thing gets closer and closer to 4/5. It's never actually going to get there, though. All right? I can show you with the graph. It was x squared minus 4x over x squared minus 3x minus 4. Right? That was it. Come on, you're not going to give me a graph? Did I pass it already? Oh, there it is. All right, here it is. Here's the graph of this function. As we go closer and closer to 4, can you see where that thing is crossing there? Right there? Right around there? What's our y value look like it's getting closer? A little bit under 1, right? It's 4/5. So as you come in from the left or the right, it's headed towards 4/5. But what's actually at 4 that we can't tell from the computer? What's actually, if I try and plug 4 in, what do we get? Undefined. So what's actually there that you can't see? A hole. We actually have a hole in the graph. The computer doesn't show you that, and even if you zoomed in, you wouldn't see it. So the computer won't show you that hole, but there is one there. All right? Does everyone understand what we did algebraically and how it connects to the picture? Coming in from both sides, we're approaching a y value of 4/5. Okay. The table is kind of sucks now compared to this, right? Because all those things you have to plug in. But you might be begging for the table in a little while, the way you were doing it. It depends on your algebra. It all depends on how comfortable you are with algebra, really. So let's try another one. Let's try limit x approaches 2. I'm making this up. Well, yeah, I'll just make this one up. X squared minus 4x over x squared minus 3x minus 4. So this is the same exact problem as the one we just did, isn't it? Isn't that the same exact problem? Except x is going to 2 instead of 4 now, right? So the first thing I'm going to do is direct substitution. I'm going to just see what happens if x goes to 2. On the top, what do I have? 2 squared minus 4 times 2, so 8 over 2 squared minus 3 times 2 minus 4. So what do we have upstairs there? 4 minus 8, negative 4, right? Over on the bottom. 4 minus 6 minus 4. Negative 6, which is just 2/3. Is that it? So what do? That's my answer. Because I did not get 0 over 0, right? I didn't get anything crazy. Because I didn't get anything crazy, my answer is just 2/3. So I'm going to say equals 2/3. I'm going to box it up, and that's my answer. If I go back to my picture, I was approaching what this time? And it was the exact same function. I was approaching what? 2. So if I go 2 here, I go up to the graph, right in there. The y value is about 2/3. It's getting closer and closer. So I come in from the left, it's approaching 2/3. Coming from the right, it's approaching 2/3. What's happening at 2? It's 2/3. Why? Because I don't have division by 0. So there's not a hole there. See the difference between the two? Okay. The what? Well, here's the lesson in this. The first step to calculating any limit is to do direct substitution. Because what happens is you start to realize how much algebra is involved in these other ones later. And so you start kind of like every time you see a limit, you start trying to do something to it. Algebraically, you try messing with it. When if you just would have plugged in the very beginning, it would have been something nice. So you just don't want to get the carriage in front of the horse, so to speak. Always do that first step and then proceed. All right, next problem. Limit h goes to 0, 2 plus h cubed minus 8 over h. First step is direct substitution, right? If we plug in 0 for h, I'm going to get 2 plus 0 cubed minus 8 over 0. So 2 plus 0 on top is 2 cubed is 8. 8 minus 8 is 0. So I get 0 over 0. And this is a bad thing. I guess it depends on what you think good and bad is, right? If you like this stuff, it's actually a good thing because now you get to do some calculus. If you aren't a fan of all the algebra that we're going to have to do, then you may not like it. All right, so the only thing I can do is some sort of algebraic manipulation to this, right? In the previous problem, we had, let's see, the one that worked out for us, we want to start noticing a little pattern here. This is the one that we did first, right? The problem was plugging in 4 gave us division by 0, yes? But when we did the algebra to it, this right here is what would have given us division by 0, right there, that part. Notice that when we did the algebra, that went away, didn't it? That's kind of what we want to happen when we start doing our algebra, is when we look at this, we say, all right, I really want this bad part to go away. The part that's giving me division by 0. I want it to not be here. The only way this h won't be here is if there's an h up here, right? That I can cancel with it. But how in the heck am I going to get an h out of this? Have to expand this? That means I have to do 2 plus h times 2 plus h times 2 plus h. I could do that, right? That is a fair, legitimate algebraic move to multiply that all out. All right. So I may as well just get a little scratch work here on the side and figure out what 2 plus h cubed is. That means 2 plus h times 2 plus h times 2 plus h, right? So how would you do that? Would you maybe do 2 of them together first, like those 2 first? Do FOIL on that. If you do FOIL on that, you would get, and I'm going to do it in my head and do it, combine everything together. That's what you would get if you multiplied those together. And then you would have to then take this one and distribute through and distribute here like that. And then you put them all together and you get h cubed plus 6h squared plus, hold on, 12h plus 8, pretty sure. But then here's Wolfram alpha, which we love, right? 2 plus h cubed. I'm not using Wolfram alpha to do my math. I'm doing Wolfram alpha to check my math. h cubed plus 6h squared plus 12h plus 8. Right? That's what you would have to do. Expand that all out, show your work on a test, and then rewrite the problem. So I'm now rewriting this. Do I still write the limit? Yes, because I haven't let h go to 0 yet, right? All I'm trying to do is rewrite it and get that h to cancel on the bottom. My h cubed plus 6h squared plus 12h plus 8 is just this piece right here, isn't it? But what am I going to subtract from that? 8. Oh, well, isn't that nice? Isn't it? You see what happens? After you cancel, if you let h go to 0 now, you're still going to have 0 over 0. Right? Yeah, so our step here would be now, you notice that after the 8's canceled, every term in the numerator had an h, right? And we have an h down here. So we are going to factor that h out of the top. Still writing my limit, right? I'm not letting h go to 0 yet. I'm not ready. I was going to make a comment about how much writing you're going to have to be doing and how much paper you're going to be using, but what's her name just left, and she seemed pretty sensitive about paper use. So I'll wait for her to come back before I make my comments. You should probably get to a point where your hand hurts in this class. Like, there's going to be a lot of writing with these limits because you just have to keep writing it and moving on to the next step, next step, next step. But notation is a big deal. On a test, on a quiz, if you're writing this problem down and that limit just all of a sudden vanishes and then comes back later, I count off for that. It's not completely wrong, but you have to work on keeping things where they're supposed to be, right? The limit's always going to be there until you actually let h go to 0. So I'm ready to write one more line down. I'm only doing this because I want to make sure everyone's very clear on what's still here. Okay, I want to know what happens to this now. Right, the h is canceled, so things should be good. H is going to go to 0. So now a direct substitution. Let h go to 0. H squared is 0 squared. That's going to go to 0. 6 times 0, that's going to go to 0. Plus 12, so your answer is what? 12. And you're done. So let's just talk real quick about what we're doing here. We look at a limit. First thing is direct substitution. We see if we have a problem, right? A problem would be what? Oh, no, I thought someone was at the door. 0 over 0, right? Or division by 0 at all. I mean, anytime we get division by 0, we have a problem. We're just not ready to deal with that case, where it's just division by 0. We don't have a 0 on top also. But just hang tight. That'll come. And if we do have 0 over 0, then we do some sort of algebra to try and figure out what the limit is, right? Limit. That was number 18. X approaches negative 1. X squared plus 2x plus 1 over. This is number 20. And that was probably the most important thing that I could have told you all semester long. I'm just kidding. So direct substitution comes first, right? So negative 1 squared plus 2 times negative 1 plus 1. We do not want to assume, oh yeah, it's going to be 0 over 0. until we convince ourselves it is. Is it? It's 1 minus 2 plus 1 on top. That's 0. Is having 0 on top enough for us to just be, okay, we got to do something? No, because you could get like 0 over 4. That's okay. 0 divided by 4 is 0. You just can't have 4 over 0. That would be a problem. So far, I'm not quite sure. 0 on top. On the bottom, well, yeah, that is 1 minus 1, isn't it? So 0 over 0 is a bad situation. And so I'm going to have to do some algebra or a trick, but I haven't shown you any tricks yet. I'm going to keep the limit because I'm not going to let x go to -1 yet. What I'm going to try and do is make the thing in the bottom not be bad, right? I need to make that thing in the bottom that's 0, make it somehow go away. What kind of algebra can we do on this? You see anything? How about the numerator? Can you do anything with that? You can factor, is it trinomial? Yes? What would it factor to be? X plus 1 times x plus 1 again? You could put x plus 1 squared, couldn't you? Is that right? What about the bottom? X squared minus 4. I mean, x squared. What? Exactly. This is a difference of squares, right? X to the 4th, scratch work, x to the 4th minus 1 is the same as x squared squared minus 1. So that kind of looks like a squared minus b squared equals a plus b times a minus b, right? That's how we did difference of squares. Except what's a for us? It's x squared, right? Because we have to the 4th power, so we have x squared squared. Our a is like an x squared. So it turns into x squared plus 1 times x squared minus 1. Is that what I heard? All right, that's fine. So you're all gung-ho and ready. You're like, yes, I factored. You're all happy about it. You plug -1 in right now. -1 on top still gives you 0. -1 on the bottom, right here, is going to give you 0 again. So you still have 0 over 0. Well, you didn't cancel anything, did you? So we're not quite done. There's still some more that can happen here. What? Do you see it? This next piece right here is what? You can factor it. Difference of squares again, right? Isn't that bottom right corner just difference of squares one more time? X plus 1, x minus 1? I applied difference of squares formula twice in this problem, didn't I? Now can anything cancel? The x plus 1s. Now I can only cancel one of them, right? So there and there. And isn't that the piece that was causing the problem? Because when I was plugging -1 right in there, -1 plus 1 was 0. So that should get rid of the problem. Let's see. I'm going to rewrite it. X plus 1 over x squared plus 1, and then what's still here? X minus 1. Now, my fingers are crossed. I'm hoping now that when I let x go to -1, I'm not going to get 0 over 0. What do we get? Let's see. X goes to -1 on top. So I'm applying the limit now, so I'm not writing the limit anymore. -1 plus 1 over. So I get 0 on top, right? All right. Keep going, though. -1 squared plus 1. I need to do that. And then I need to do -1 minus 1. What's -1 squared plus 1? 2. And over here, careful with that, -2, isn't it? -1 take away 1, -2. So I'm getting 0 over 2 times -2, which is really 0 over negative 4, which is 0. So my answer is 0. Anyone have a question? Everyone follow that? It's okay to have 0 on the top and something other than 0 on the bottom. That is okay, and then your answer is just whatever that is. So what have we needed to be able to do so far? We needed to be able to factor a trinomial, expand something. We've needed to do difference of squares twice, right? So far, this is all pretty standard algebra. So while I'm writing number 22 down, I was saying that your hand might start to hurt in this class because there's a lot of writing. And I know that wasting paper is an issue for some people. So let me give you some reassurance, if this makes you feel any better. I know we're all concerned about the planet, right? We're all concerned about taking care of things here. So anyone taken astronomy yet? Has anyone taken an astronomy course? Yes? So you learned about main sequence stars? Intro to... Our sun is a star, right? And if you look at all the stars that we can pretty much see, ours is about an average star. It's nothing special. It's not real big. It's not real small. It's just average. And average stars have certain lifespans. And when they get to a certain point where they start running out of fuel, it's kind of like they have one big last gasp and they go, and then they burn out. And when they do that, they expand. They're going to pretty much take the Earth out with it, with that expansion, and everything on this planet is going to get recycled. So, you know, paper here, paper there, tree here. It's all going back. It's all getting turned into little atoms, you know, at some point. So, you know, just don't beat yourself up about paper, you know. Tear a new sheet, make a mistake, crumble it up, throw it away, and just look at it as being a gift to the sun at some point. All right? That's the way I try to do it so I don't have to think about it. You know, I just say, don't worry about recycling. In fact, in my house, my wife figured this out a few years ago. I have like the trash and the recycle, and then she realized that I take them to the same place. Like once they leave the house, they go to the same place. It's just like that psychological appearance of, yes, we are recycling. We feel good about ourselves. How many of you have heard that there's more pollution created by the trucks that drive around picking up the recycling stuff than what you save in recycling, right? Just all the pollution required to take all the stuff and recycle it, the energy required to do that counters the benefit. But if it makes you feel good, you know, sometimes we just like to make ourselves feel good. All right, I was distracting you from this, trying to give you something to get your mind off of the horror that now presents itself on the board. Direct substitution. We do get 0, 0? Yeah, because it becomes like square root of 9 minus 3 over 0. Yeah, so we get 0 over 0, and we're not happy about it. Especially now. Because everything we've done up to this point has been some algebra that you pretty much have seen that seemed kind of standard. Difference of squares. I mean, it's not like I would expect anyone here has never seen difference of squares. Factoring a trinomial, I think everybody has factored a trinomial at some point in their life, right? This, however, is not as natural. It doesn't flow like the other ones have flown. Now, what you cannot do is just say, hey, I'm going to square everything. The only time you can ever square something is if you have an equation and you square both sides. You can never take a fraction and just decide to square it. It's kind of like if I say, hey, here's 2/3, everyone. You can't come in there and say, okay, I'm going to square it. It's 4/9. Those aren't the same thing anymore, right? 4/9 is not 2/3. Now, if I have x equals 2/3, I'm more than free to square both sides. That's okay. So don't make the mistake of just saying, I'm going to get rid of the square root by just squaring it. You can't do it. All right, so we need something, right? This is a bad situation. We need some sort of algebra or some sort of trick. Now, what I'm going to do is going to be algebra, but what you might consider it is a trick, because it's a little tricky. Anytime that you are faced with a limit and you're looking at a square root, as we are here, you might want to try to introduce a hidden 1 right here. So everyone agree that there's a 1 next to that being multiplied? Yes? If I multiply anything by 1, it stays the same. But the one that I'm going to choose is going to be extremely clever. And the only reason I know to do it is because someone showed me how to do it, and that's because Isaac Newton figured it out that you could do all this. Well, he didn't really figure it out. He just really messed with the algebra enough. So watch my clever 1 come in here. Okay, I'm going to rewrite the line. Thinking about the sun. We're not worried about it. If you took offense to my sun thing, I'm just kidding, okay? Like, I'm just trying to make this class have a little bit of something other than what's happening up here. Okay, here comes my 1. It's going to be something you may have heard the name before, the conjugate. I'm going to write down the square root of 4u plus 1, but then I'm going to put plus 3 instead of minus 3. And I'm going to do that to both the top and the bottom, because that's 1, isn't it? So because I see a square root up here, and because I couldn't really do any other algebra that I could think of, I'm going to introduce this conjugate. Now the conjugate is the part that has the square root in it, right? It's that same exact expression, changing the sign that's in between. Had that been a plus, I would have used a minus over there, right? That's it. Have y'all seen the conjugate before? With imaginary numbers, you may have seen it. They call it the complex conjugate. Here's just the conjugate. So by multiplying, let's see what effect we have. I'm also going to put some parentheses. Now the parentheses are only going to be so I can keep track of things here. How many terms do I have in the top left here? 2. How many terms here? 2. So I will have to FOIL if I multiply those together, right? Here I have 2. Here I have 2. Right? Now, start with the top. Rewrite the limit. Your hand cramps. First multiplication. Square root of 4u plus 1 times square root of 4u plus 1 is just 4u plus 1, right? The roots go away because you're squaring a square root. So you just get 4u plus 1. Now, what about the inside terms? What's going to happen to them? They're going to cancel. They will always cancel. That's the whole reason why we use conjugates, because when you multiply a root by its conjugate like that, the roots will cancel. But I'll show it. When you do this one times this one, you get plus 3 times that root. And when you do the one on the inside, you get a minus 3 times that root. And we still have one more multiplication to make, right? Which one? Negative 3 times 3, which is negative 9, right? Are we done on top? Have I done the whole FOIL out there? Okay, now the bottom. Here's my advice to you on the bottom. Don't touch it. Why not? Why do you think I shouldn't touch it? What's my goal? To get that part that's causing the division by 0, the u minus 2, to make it cancel, right? So if I start multiplying it all through there, I might lose it in there, and it'll be harder to cancel later. So the standard protocol here is multiply out the numerator, keep the denominator just as 2 things, u minus 2, then in parentheses, square root 4u plus 1 plus 3. Yes. Well, let me cancel the insides first, okay? I'm going to cancel those out, right? And let's add 1 and -9 together to get -8. And let me rewrite it. Why? Because I'm not afraid of rewriting it. In fact, I'm being more green than you are. Look, I'm not even writing on paper. Everyone in here was wasting paper, and I you know, so. But you waste your paper, okay? 4u minus 8 over u minus 2 times square root 4u plus 1 plus 3. I can't help but think of things I've done in my past where it took a lot of practice to get good at it. I don't know, the first thing came to mind was like riding a bike. If you've ever ridden a bike out like on a trail somewhere, like in the dirt, going over hills, if you keep going through those trails over and over, the same ones over and over and over, you start to just subconsciously pick up all the little nuances of the trail. You can start to go faster because you're expecting things you don't even have to think about anymore, right? Anything that you do that you enjoy, if you've done it enough, you just start to just naturally do it. Same thing with the calculus. You can sit here, you can watch me do it, you can say, yeah, I see how that happens, but until you actually sit there doing your homework saying, and start picking up all the little bends and curves in the course in algebra, you really don't get good at it. So practice, practice, practice. At this point, what? That 4. So you see that if you factor a 4 out of the numerator, you'll have your u minus 2, which you're trying to cancel. I'm not afraid. I'm writing it again. We're almost there. We're almost to the end of this problem. Now I will cancel. And I'm writing it one last time with the cancellation. And then I'm going to come in here and I'm going to let u go to 2. So now, no more limit. I'm letting u become 2. The top doesn't change. It's just 4 over square root of 4 times 2 plus 1. That's square root of 9 plus 3. It's 4 over 6, which is 2/3. Whew. It's a lot of work. So in this problem, in the very beginning, if u was approaching 2, we had division by 0. We had 0 over 0. But we know that now, if you look at this thing, as you come in from the left and right, it's actually approaching 2/3. But it required here what? For us to bring in what? What algebra, what trick did we need here? The conjugate, all right? So we're starting to, like, when we're doing these limits, we want to start kind of in our head, start lining up the tools that we might need. You know, like you're working on a problem, okay, I need to be able to factor difference of squares. Or, okay, yeah, that conjugate thing I've done, you know, you just bring out whatever tool you need for it. You do enough of these, you get a whole tool shed full of stuff. All right, number 24. Limit. Y'all doing okay? I know it's a Monday. I had a real hard time getting out of bed today. Limit. Me too. Me too. Good thing one of my students called and asked where I was. I wasn't in my office. No, I was there. I'm just kidding. I've only missed one important thing in my entire career teaching. I missed a final once. I was like, my student called me and was like, hey, where are you? I'm like, oh. But luckily I had already made the final, so I had them go get it off my desk and hand it out to everyone. But I missed the final. That's pretty bad, huh? I overslept. Yeah. It happens, right? No, I didn't forget that I just slept in. That was a long time ago. All right, here we go. Let t go to 0. Direct substitution. Let's see what happens. You get 1 over 0 minus 1 over 0 again. Wait a minute, but I thought anything minus itself was 0, right? Isn't like 2 minus 2 0? Isn't 3 minus 3 0? Isn't 4 minus 4 0? So isn't this 0? No, because 1 over 0 is not even defined, so you can't just say that. So we're still in a bad situation. Do you see that? We're in a bad situation. If it helps you to put a little bad, unhappy face there, you can do that too. It's not going to take off that. What now? That is an option. Common denominator? Why? Why? Why not, right? Why? Try it, right? Try something, do something, right? Just don't sit there and don't do anything. Try something. You gotta take a swing. It's kind of like the lottery, right? You can't win the lottery if you don't play. Well, you can't get this problem. You're not going to go anywhere if you don't try something. So combining two terms together, getting common denominator, is a fair algebraic move, right? I mean, that is fair. Maybe it will lead us to what we want, which is no more division by 0. So how do we get common denominators between things? You make the denominators match, exactly, right? And whatever this one's missing, you put it on top and bottom. Whatever this one's missing, on top and bottom, right? Okay, so here's some real quick scratch work on the side. Let me write these things out because we don't want to go and do too much work. Do you agree on the second fraction over there? I could pull a t out. Whenever I get to a problem like this, I always notice this and I always point out to my students, just a little notation thing. Can you tell the difference between my pluses and my t's? Because I curl my t's. If you're going to be an engineer, you might want to start doing little subtle things like that for yourself, because I didn't always curl my t's. It was just by necessity. Stop confusing things. Curling your t's, striking your z's, things like that are little things that you kind of pick up that help you later. All right, common denominator. They both have a t, don't they? So the only thing that's really missing is this one needs what? T plus 1 on the top and bottom. So I introduce a t plus 1 on top, introduce t plus 1 on the bottom. Do y'all follow what I'm doing? No questions? I graded your quizzes last time. I'll hand those back, but I'm going to hand the sign-in sheet around, or I'm going to pass it around. I realize, no, this class is okay. My other class, the dates are all wrong. September 8th, initial by your name, pass it along. So we're good with this? No questions on what I'm doing? So the top one here, this top becomes t plus 1 over t times t plus 1. Minus, this one is just 1 over t times t plus 1. Now that they have the same denominator, I can put them together. The thing we have to be careful with is that minus sign, right? This one? Like right now, it's not going to be that big of a deal. It's going to be minus 1. But if there were more than one term over there, we would have to apply that negative to both or put it in parentheses. So this is going to become t plus 1 minus 1 over my common denominator t times t plus 1, which now that's what I'm going to write back over here. I'm ready to come back to the problem and write it down again. Limit t goes to 0, and that whole thing became, what did we say? What is that? T plus 1 minus 1, which I'm just going to put t over t times t plus 1. Do you see what's going to happen there? These ones canceled. I had t over t. These t's are going to cancel. Now, I didn't cancel them yet. I could have done them down there, but I left them because I want to make sure everyone understood, like, we want that to happen, right? We are very, very much in favor of this cancellation because that's where we're having the problem, right? Any questions? I am going to rewrite the limit. I'm not ready to let it go yet. I don't want this problem to be over. What's still on the bottom? T plus 1. And what's on the top? Be careful. When you cancel the t, you still have a 1 up there. Don't lose that 1. It's still a fraction. And now, finally, let t go to 0. And you get 1 over 1, which is 1, which is our answer. So the answer is 1. You ready for another one? Of course you are. I'm thinking I might make this one up. Hold on. I'm going to do 28. Anyone else need to sign in? All right, without doing any of the work, this does go to 0 over 0. Okay, I'm not going to show that, but it does. And that means I need some algebra. So what are you thinking here? Common denominator? Okay. I will point out, what was your name, ma'am? I'm sorry. Kara. Remember when I told them on Friday I do mine a little different on this part? I get the common denominator, but that's just, I'm pointing it out, that it'll look a little different than what I did that day. Okay, so I'm a fan of putting these two together and getting a common denominator and putting them together like that. So I'm going to do that on the side. I got 1 over x plus h squared, and then I've got minus 1 over x squared. So when it comes to common denominator, all I'm going to be able to do is on this first one, put an x squared on the top and bottom, and on the other one, put what? X plus h squared on top and bottom. That's about all I can do. They'll both have the same denominators, but the numerators will be a little different. So I should be at x squared over x squared times x plus h squared minus, I don't need that 1 there, x plus h squared over x squared, x plus 1, or x plus h squared. Now, to put them together, I need to be careful with that subtraction, right? So I'm just going to put minus x plus h squared. Do you all agree that's what this becomes if I get a common denominator? All right, let me go back to the limit then and just write it down. I have limit h goes to 0. What am I hoping is going to cancel at some point here? H, right? So I have x minus x plus h squared over the common denominator, x squared, x plus h squared, all of this over h. Anybody see what I can do? Because that doesn't look like it made it any easier or any better. How do you... Do what? So flip that one up as 1 over h. We did that when we were doing difference quotients, right? You're just one step ahead, though. We need to do something first, because h isn't going to cancel with anything if we bring it up here, right? There's not an h sitting up here to cancel with. I do want you to expand. I want you to expand this right here, and then subtract it, which means it's going to have to subtract every term, right? Every single one of those. Mine is going to have to go through everything. So let's do it. You may not want to, but let's do it. Limit h goes 0, x squared minus x squared plus 2xh plus h squared. I left it in parentheses. All right. Distribute. All the signs change. Minus x squared minus 2xh minus h squared all over no apology. Forget it. Never mind. Yeah, so that's that kind of critical algebra thing here. We expanded that out, and then the minus has to go to each one, so it turns all the terms negative. And do you see the good thing that's about to happen? Those x squareds go away. And now what do these two terms have in them still? H's. Yeah, that's supposed to be h to 0. It said h to 0. I don't know what you're talking about. Thank you for pointing that out. Those are the little things that I don't like to make little mistakes on. All right, now, can we factor an h out of the top? Okay. Anybody's hand hurt, or are you okay? All of this over h, right? But we said we could bring that h, flip it as a reciprocal. I'm going to do that. I'm doing it red so everyone understands that's what happened. This h here is really like an h over 1, and then we just bring it up as a 1 over h on the side. And that helps, hopefully, for you to see that those h's will cancel. And now, I'm ready to write it one last time. And I'm ready to let h go to 0. Okay, let h go to 0. What does the top become? Just negative 2x, right? And the bottom? X squared times x squared again, right? X squared times x squared is x to the 4th, isn't it? And if I have an x on top and an x to the 4th on the bottom, that's what? It's really like an x cubed on the bottom? Agree? Now let me tell you something that's probably the secret to calculus. This one thing will let you solve all problems that you'll ever do. But we'll wait for a second. He's not paying attention. I was kidding. There is no secret, right? All right, so how do y'all feel? Algebra is okay? Yes. Like how this came about? Oh, here? Okay, so look, this is going to 0, right? Like that goes to 0. So it's just like a negative 2x. And then here, this goes to 0. That's really like x plus 0 is x. Mm-hmm. Yep. Okay. Oh, that's a 3. It's a 3. Did it look like a 5? Okay. It was, yeah, it wasn't great. That right there is x to the 1 over x to the 4, which is x to the 1 minus 4, which is x to negative 3, which means you have a 3 down the denominator. Or just cancel an x. Yes. No, but as long as you said something like, I use like SW, scratch work, as long as it's separated from the rest of the problem, you eventually come back to the limit and carry the limit, that's okay with me. This is the type of thing I don't like seeing though. Like this will go to this, and then all of a sudden it'll be like limits here again, and then you get an answer. It just, that, I understand what you're doing, but it's just not, it's like writing a paragraph in an English class and not using, you know, periods and exclamations, and just, it just doesn't, you know what I'm saying, right? All right, well, we've got about 20 minutes left. And I think the rest of the algebra that you're going to see in that section is going to be, you know, like when you do your homework, you know, you're just going to have to kind of work through it and see how it works out, you know. Now, there's some other parts of this section that some other instructors are pretty big on. Not big on, but they include, like, they do some stuff with absolute value functions and some piecewise functions. And I pretty much kind of don't do that as much. So it's not going to hurt you. I mean, I teach Cal 2, Cal 3. Like, I know kind of what you're going to need, kind of what you're not going to need. So I kind of don't do that part of it. But I do skip through and I get into some problems later on. So I need to introduce you to one more thing before we can wrap this section up. It's those two major formulas that I said you should know, that I gave the quiz on. Bonus, I should say. It was this one and this one. If you let x go to 0 here, okay, if you let x go to 0 here, what is sine of 0? 0. And then x goes to 0 here, you get 0. So you get 0 over 0, right, which is bad. You have to do some algebra. There is no algebra you can do, all right? There's nothing you're going to be able to do to this to ever figure it out. So some limits you just can't do easily. But you're just going to take it on faith right now that it's 1. And I will show you later on in this class why it's 1, but just not yet. You have to wait. If you're like gung-ho, you have to know now, I have a way of showing you. It's a 30-minute to an hour session in my office, which I'm more than happy to show you. But you have to come to me for that. All right. Then this one. X goes to 0. Cosine of 0, we all know, is 1. Minus 1 is 0. Over 0, we get 0 over 0. This one is 0. I forgot to put the thing there. Okay? Now, this is the way the book presents this to you. The way that I like to present it to my students is slightly different than this. It's kind of more general. I think it's more powerful. I want you to look at this first limit in a different kind of way. If you have a limit, and I'm going to say that we don't care even what's happening down here. In other words, you could have x going to 0, you could have x going to 2, you could have h going to 0, h going to pi. I don't care what it is. Okay? Just don't care. And then up top you have sine, and inside of sine you have something which I like to call junk. And in the bottom you also have something which I will call junk. So in this problem, x is going to 0, right? In the formula that's in the book, x is going to 0. We have sine of junk over junk. So the junk up here is what? The x and the x, right? Okay. The answer to this will be 1 if two conditions are met. If the junk is equal, well, I should say same, top and bottom. That means whatever's in the sign has to match exactly what's down there. Exactly the same thing. So in this problem up here, if this was sine 2x over x, it would not work. All right? They have to be identical. That's the first condition. The second condition is in the limit, the junk, arrow 0. What does that mean? What do you think I mean? In the limit. So when you take that limit, the junk that you have in there, what? Needs to be approaching 0. So if the junk goes to 0 and the junk is the same on top and bottom, then the answer is 1. Example. Limit. X goes to pi. Sine x minus pi over x minus pi. That's 1? That limit's 1? Okay, do you have junk? Are they identical? Yes. Okay, if x goes to pi, is the junk going to 0? If x goes to pi, what's pi minus pi? 0, right? And pi minus pi is 0 there. So they're both going to 0? As x goes to pi, both of these things are going to 0. So yes, the answer is 1. How about this? Limit x goes to 4. Sine x minus 4 over x squared minus 4x. Close. Well, what did you say? It doesn't factor to what? X. Okay, yes. But does it match this right here? Does it look like this? Why not? This right here is our junk, right? This junk has to match. It doesn't match. But I could do this. Could factor the bottom, right? I could pull an x out, be left with x minus 4. Now please do not cancel these, right? Don't cancel those. X minus 4 is the argument of the sine function. It's trapped in the sine function. It is not being multiplied, so you can't cancel. But what you could do, and I'm out of room, so I'm going to come up here with this. You could rewrite this as limit x goes to 4 of 1 over x times sine x minus 4 times x minus 4. Do you agree with that? That's just multiplication of fractions, right? If I multiply this fraction times this fraction, you just go straight across, so you get back to here. Why would I write it like that? Because this right here is sine of junk over junk, and the junk matches exactly, and the junk goes to 0, doesn't it? Because when I let x become 4, I get zeros in both of those. So that's going to go to what? 1. Times, now over here, direct substitution, 1 divided by 4 is 1/4. So the answer is 1/4 times 1, which is 1/4. Are y'all okay with that? This part right here, 1 over x, just direct substitution. Let x go to 4, you get 1 over 4, right? There's no division by 0 there, there's no problems. The other one, this right here, this piece, was this part right here. Now, I have multiplication between these, right? So I can just do each one individually. That's one of our limit laws. If you have two things and you want to take the limit and they're being multiplied, just do each one separately, which I did. Do this one, it's 1. Do this one, it's 1/4. Multiply together, get 1/4. Questions? All right. Here we go. That was all just to lead us into this. Find the limit as x approaches 0, sine of 3x over tangent of 4x. Can I just cancel the x's? No. Well, let's just make sure we know what's happening here. Sine of, let's do direct substitution. This is sine of 3 times 0 over tangent of 3 times 0, no, not 3 times 0, 4 times 0. So isn't that sine 0 over tangent 0? And maybe you need to go back and look at the graphs, or maybe you just know it. Here's the sine function. What's sine of 0? 0. Here's the tangent function. Maybe you remember this. Remember it had those cool little asymptotes like this? So what's tangent 0? 0. So you get 0 over 0, which means you got to do something about it, right? You got to do something about it. Tell me if you agree with this. Do you agree with that? All I did was just broke those two fractions apart, right? Now you'll see where I'm headed with this, but just make sure you understand what I did there. What I'm trying to do is figure out what's causing the problem. Like, we know it's the division by 0 that I don't like, right? So I need that tangent to cancel. The problem is I can't cancel a tangent if I don't have a tangent up here. I have a sine up there. So the standard technique that I like to tell the Cal 1 students to do is, whenever faced with something like this, rewrite everything in terms of sine and cosine. What is tangent? By definition, tangent of theta is sine theta over cosine theta. Y'all remember that? So what is 1 over tangent? That's cotangent, right? Cotangent is cosine over sine. So what I'm going to do is I'm going to rewrite this as cosine over sine, But I'm not going to say theta. It's cosine what? 4x over what? Sine 4x. So can I do that over here? Is that okay? Cosine 4x over sine 4x. I've pulled them apart, but that, if you put them together, that would have been your cotangent 4x, right? Anybody have any issues with what I did? Well, what's up here is 1 over tangent, right? 1 over tangent is cotangent. Cotangent is the reciprocal of tangent. So cosine would be on top and sine would be on bottom. Yes. I guess we get to the same place. You mean replace this right here with sine 4x over cosine 4x and then just flip it? We get the same place, yeah. What I was trying to get you to see is that I like to pull everything apart. What, this right here? Well, you got to see what I'm about to do first, because you'll appreciate it being pulled apart, I think, in a second. All right, so let's identify the part that's causing the problem. Because I haven't taken the limit, have I? No. I just pulled everything apart, and I haven't told you why I'm doing that yet. I'm going to look at the piece that's causing the problem. Right? That's it right there? It's pretty obvious that when x is 0, 4 times 0 is 0, sine of 0 is 0. There's my division by 0. This is not division by 0, is it? Sine of 0 is 0. 0 over 1 is 0. That's okay. Cosine of 0 is 1. 1 over 1 is 1. Who cares? 1 over 0 is the part that's causing the problem. So I need to somehow eliminate that problem. Going back to what we just did, this sine junk over junk formula, this sine junk over junk formula actually works both ways. And I would like for you to make sure you put this here. In other words, if you have the junk up here and the sine junk down here, it will also equal 1. So if you flip it over, in other words, you still get 1 no matter what. It's really because this right here is just the reciprocal of this. And if the answer to this is 1, then the answer to this is the reciprocal of 1, which is 1. So you get the same result. But let's get back to this. So what would be a way that I could make this not be division by 0? It would be to make this, I don't know, something I know the answer, but it's not 0. So what could I do? Sine junk, what would be nice to have up here? What would make my life just so great if I had what up there? 4x, right? Wouldn't that be nice? That'd be great. Well, I'm going to make a 4x appear. But to do it, I'm going to put a 4x on top and bottom over here next to it, like this. Now, I can do that. Why? That's like a 1, right? It's like a 1. I'm introducing a 1. But because the numerator is multiplication, multiply, 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 you can slide things around, can't you? Multiplication is commutative. So I can slide this 4x over here on top as long as I leave a 1 on the bottom over there, or on the top over there, right? Yes? Now I'll write it all out. Now let's run through everything again. If I take the limit right now, is this a problem? Sine 3x over 1. Is that a problem? No. 0 divided by 1. Cosine 4x over 1? No. This? What is this now going to become? 4x over sine 4x. 1. 1 over 0. So we have a problem again, don't we? So I fixed one problem, created a new one, didn't I? Yes? Here's, I guess, the trickiest part of the whole thing, I guess. I don't know. You tell me. Anyone see something I could do? Clever little move here? What's that? Well, don't cancel this. That's where we'd be back where we came from, right? Okay, let me just show you because we're almost out of time. I'm going to use the power of that junk over junk against itself right now. Really, the biggest problem I have is this x right here, right? Because that goes to 0 and I get division by 0. What I'm going to realize right now is because there's multiplication, I could slide that x all the way down here. Oops, too far. All the way down here and place it right underneath the sign, right? Now I have sine 3x over x, just the x. I just brought the x. What else would I need there to make this be something good? A 3, right? So why not come down here and add a 3 over 3 and grab that 3 and pull that 3 down here and slide it underneath also. It's just being clever. That's all it is. It's like a trick, right? And now let me rewrite everything. I would have limit x would go to 0. I'd have sine 3x over what? 3x. I have cosine 4x over 1. I have 4x over sine 4x. I have, what's left over here? 1 over 4, and then what about the last one? I pulled that 3 off the bottom, didn't I? So 3 over 1. You said 3/4. That you could have done that also. And now it's a limit time. Try and see if we have any issues. Where does this thing go? 1 times. Where does this thing go? 1 times. Where does this one go? 1. 1/4. Remember, limit of a constant is the constant. The answer is 3/4. Because cosine, when you plug in 0 for x, it's cosine of 0. And then cosine of 0 off of its graph is 1. Okay, your homework assignment. I don't think I did enough of those for you to really be comfortable. So you're just going to have to see how you do on the homework. Your homework assignment is on your schedule, right? Okay. Omit these problems. Do not do the following problems. 1, 2, 5, 9. $43, $44. Those are the ones you met. So do everything else that's on here. And I'm just going to say for problems 49 through 65, the ones that are on here that cover 49 through 65, that's what we just did right now. So you might struggle with those. I'm just giving you a warning on those. That's it. Because I only showed you one example. All the others, you know, there's a lot of evens in there that I already did in class. So I would make sure you do at least all the odds that are on that list. Okay, do your homework. Be ready next class. I don't want to give a quiz like I did today and be disappointed. Well, that's all right. If you want your quiz from last time, I can hand it back to you if you want to wait.